going to demonstrate how to use potentiometer as a sensor to control servo motor. So you can see we include the library named uh, servo to declare that we are using a servo motor here. So we declare an object named myServo, and this line is to declare that our potentiometer is connected to the pin 0 of the analog pin, which is E0, and then we declare a variable named val to read the potentiometer value, and the value which uh, will help to scale, or it will represent the value of a scaled value from the potentiometer. So for the setup, we declare that the serial monitor is initialized, and then the servo motor is attached to the pin 9. So in our loop, we declare that val is equal to the value read in the potentiometer, and then the value is the scaled value from the potentiometer, which ranges from 0 to 1023, and it will be scaled down to 0 to 179. So the myServo.write is where we set the position of the servo motor according to the scaled value, and then the serial print, which prints the scaled value or the angle of the servo motor, and then it has a delay of 15 milliseconds. So the code is uploaded. Let's try to look it up in our serial monitor. We will go to tools and then serial monitor. So as we can see, the lowest value is 1. So as we try to rotate it, it increases the value of the potentiometer. So its maximum value is around 178 to 179. And as we lower it, the maximum or the minimum value for the potentiometer is 1 degrees. Challenge where we display the value of potentiometer and its angle to the serial monitor. So for the code, it's the same as before up to this code, which will position the servo motor according to its angle, but we added some uh, commands. So first we will print the label, which is the potentiometer value, and then it will indicate also the value from the potentiometer from 0 to 1023, and then a comma to separate the two, and then the value, the angle, and the value from the scaled value from 0 to 179. And then the slash n, it means to added it to the new line. So we will try to upload this one. So it's uploading. So now it is uploaded. Let's open our serial monitor. So as we can see, the lowest value detected is around 3 or 4 degrees with a potentiometer value of around 20 to 23. So let's try to have an angle of around 20. So there it is. It's not stable since there are some errors in detecting the value. But when the value is 20, it's around 119 to 120 in the value of the potentiometer. But the angle registered here is 20 degrees. Let's try to have a 40-degree angle. So as we can see, for around 40, the value of the potentiometer is around 232 to 234 bits. So, enable to have an angle of 40 degrees in the servo motor. So, the servo motor also has an angle of 40 degrees. So, let's move it to 60. So there it is, an angle of 60 degrees with a potentiometer value of 345. So let's proceed it to 80 degrees.
This is that one.
So for 80-degree angle, we have a potentiometer value of around 458 to 459. And the servo motor also increased by an increase or position at 80-degree angle. Let's try 100 degrees. So for the 100-degree angle, the potentiometer value is around 576 degrees. 576 bits for the potentiometer value, while the servo motor is positioned at a 100-degree angle. So as we increment it by 20, so we can see that 120 degrees is equal to 690 to 91 in terms of the value for the potentiometer, and it is positioned also at 120 degrees in the servo motor. So by adding again an increment of 20, we can see at angle of 140 degrees, the servo motor is positioned also at angle of 140 degrees, and the potentiometer value is around 802 to 804 bits. So added by another 20 degrees, so we can see at 160 degrees, it has the value of 915 bits on the potentiometer, and it is positioned also in 160 degrees. So for the last, it's around 180, or we determine the maximum value of the potentiometer, which is 179. As we can see, we will plotted a 1023 bit, which determines this is the maximum value for the potentiometer to display the value of potentiometer and the angle in the liquid crystal display or LCD. So for this one, we include the servo motor, which to determine its position, wire H, since we are using I squared C protocol, since the LCD we use is there is a I squared C module included. So we will include also the library for the liquid crystal display with I squared C protocol. So we can see we declare that the liquid crystal display I squared C LCD is said to be had an address of 27 and with the 16 characters with 2 rows. So the same code, we declare the servo object, the pins for potentiometer, the integers for the values, and for the setup we initialize the LCD and we declare the servo motor is attached to pin 9. So we declare the val is the value from the potentiometer, the value is the scaled value from the potentiometer, and the position are written. So for this one, we set the potentiometer value at 0, 0. This is the code for the display, which is on the upper row, that we will print the pot value and then the val or the value of the potentiometer, and with space to avoid overlapping of the previous data. So this one is from the second row, which will display the angle, and the value from the scaled value, which represents the angle, and the spaces to avoid overlapping of values. So we will upload this one. As we can see, the code is already uploading, and now the code is being uploaded. So the code is being uploaded. So as we can see, the lowest value determined by our potentiometer is 4 degrees, and we had the potentiometer value of 28. So as of now, the servo motor is positioned at 4 degrees. Let's increase it up to 20 degrees. There. So we can see that the angle at 20 degrees has a potentiometer value of 115. And if we increase it up to 40, there, as we can see, the potentiometer value at 40 degree angle has a value of around 233 bits. So the potentiometer is positioned at to have a value of 233, which scaled to 40 degrees, which the servo motor is also positioned at 40 degrees. So if we increase it up to 60, we can see at 60 degrees we have the potentiometer value of 347, and the servo motor is also positioned at 60 degree angle. So if we increase it up to 80, there we can see that the potentiometer value is 459 and the servo motor is positioned at an angle of 80 degrees. So if we increase it up to 100, there we can see that the potentiometer value is 576 or 577, and the servo motor is positioned at an angle of 100 degrees. So let's try to increase it up to 120. There we can see that the potentiometer value is around 688, and the servo motor is positioned at a 120 degree angle. So increase it up to 140 degrees. There it has the value of 801 bits, and the servo motor is positioned at an angle of 140 degrees. Let's increase it up to 160. There, as we can see, the value of the potentiometer is around 917 to 118. So the servo motor also is positioned at 160 degree angle, and for 180 degrees, or the maximum degree, we can see that the maximum degree for, or maximum angle of the servo motor is around 178, with the potentiometer value of 1018, and this is also the maximum position that a server can do. Hope you like this video, and see you again next time.